Today we'll start 4-3 prime factorization. We'll learn to write prime factorization of composite numbers, and we'll learn to factor monomials. We'll start by looking at the definitions of a prime number and a composite number. A prime number is a whole number that has exactly two factors, 1 and itself. I've listed some of those for you to look at. They start with 2, and 2 is the only even prime number. A composite number is a whole number that has more than two factors. Some of these are even and some are odd. That doesn't have anything to do with whether or not it's composite. It depends on how many factors the number has. So 9 is odd, but it has more than two factors. The factors of 9 are 1, 3, and 9. 0 and 1 are neither prime nor composite. Let's look at example 1 and learn to identify numbers as prime or composite. First, let's determine whether 17 is prime or composite. We'll do that by finding the factors of 17 and listing whole number pairs whose product is 17 like we did in lesson 4.2. The factors of 17 are 1 and 17. 1 times 17 equals 17. 17 has only two factors, therefore 17 is a prime number. Now let's determine whether 51 is prime or composite. We'll find the factors of 51 by listing the whole number pairs whose product is 51. We know that 1 times 51 equals 51, and we know that 51 is not divisible by 2. 51 is divisible by 3 because 5 plus 1 is 6, and 6 is divisible by 3. So 3 times 17 equals 51. And really at this point we don't need to do any further work because once there are more than two factors of 51, 51 is composite. Prime factorization. That's when we have a composite number and we express it as a product of prime factors. We have two methods to find prime factorization. One method is the factor tree. And that's a method that you've probably already done in the 6th and 7th grade. And then we have a new method, which you may or may not have done, called the ladder method. In example 2, we'll write the prime factorization of 66. Now remember, you can divide 66 any way you want, and you'll still get the same prime factorization. I just happen to divide it 2 times 33. 2 is prime, so now I need to find the prime factorization of 33, and that is 3 times 11. So the prime factorization of 66 is 2 times 3 times 11. We can check it by multiplying 2 times 3 equals 6 times 11 equals 66. Let's find the prime factorization of 63. We can multiply several different things to get 63, but let's start with 9 times 7. We'll notice that 7 is a prime number, so we can go ahead and circle it, but 9 we've already determined is composite, and we can multiply 3 times 3 to get 9. 3 is prime, so we can circle 3, and the prime factorization of 63 then is 3 times 3 times 7. Or we can write it using exponents, 3 squared, or 3 to the 2nd power times 7. We can also find the prime factorization by using a ladder. This is the method that I like, and it's one that we're going to use for algebra later on, and we're also going to use it for pre-algebra later on to do some factoring. So this is a good one to get familiar with. First thing I usually do is begin by reminding myself of the prime factors. So I multiply the correct things. So I go ahead and I just write 2, 3, 5, 7, and 11. There are other prime factors, but generally we're going to find one before we get to 11. So we'll write 66 in a ladder, and we'll start with the first prime number. Is 66 divisible by 2? Yes, it is. So 66 divided by 2 is 33. Is 33 divisible by 2? No. Is 33 divisible by 3? Yes. So 33 divided by 3 is 11. Is 11 divisible by 2? No, it isn't. Is it divisible by 3? No. And we can go down the line until we determine that 11 is divisible by 11, and 11 divided by 11 is 1. And when we get to 1, then we can stop. We don't have to go any further. And what we'll do then is we'll take these three factors on the outside of the ladder, 2 times 3 times 11, and multiply those together, and that would be the prime factorization of 66. Now let's find the prime factorization of 36 using the ladder method. Let's write our prime numbers to remind ourselves what they are. So we've got 2, 3, 5, 7, 11. And we'll start by asking, is 36 divisible by 2? Yes, it is. 36 divided by 2 is 18. Is 18 divisible by 2? Yes, it is. 18 divided by 2 is 9. Is 9 divisible by 2? No. So let's move to the next one. Is 9 divisible by 3? Yes. 9 divided by 3 is 3. Is 3 divisible by 3? Now notice I didn't start with 2 because once we've taken the 2 out of the answers, then nothing's going to be divisible by 2. So 3 is divisible by 3. 3 divided by 3 is 1. Once we get to the 1, we can stop, circle our factors, and the prime factorization of 36 is 2 times 2 times 3 times 3, or 2 to the second power times 3 to the second power. You can check it by multiplying 2 to the second power is 4, times 9, 3 to the second power is 9, and 4 times 9 is 36. The last thing we're going to do is factor monomials. Recall that monomials are variables, numbers, or the product of variables and or numbers. Example 3 will show us how to factor some monomials. They are not going to be any different than what we've done. You'll use the two methods that you've learned to factor the coefficient or the number that comes before the variable, and then you'll factor out the exponents like we did in previous sections. So 14w is 2 times 7 times w. 9t to the second power is 3 times 3 times t times t. And in the last example, negative 25z to the third power, we're going to have something a little different. You're always going to start with a negative 1 when you have a negative number to factor. So negative 1 times 5 times 5 times z times z times z. Here are some examples for you to do. Self-check number 1, you'll find the prime factorization of 18 using a factor tree. Self-check number 2, you will find the prime factorization of 24 using a ladder. Self-check number 3, you'll factor 21gh to the third power. And self-check number 4, factor negative 75ab to the second power. You may go back and check the video for any information that you need to complete these problems. And you'll need to complete these problems on the back side of your notes page that will be turned in for your homework tomorrow. Make sure to submit your form online as well and bring your notes page tomorrow for your homework.